So we're going to begin with density, and this right here is our, our density part of our first unit of notes. Now there's 5 sheets really, that are all together, and they all kind of make this up. So we're just going to flip through them for a minute. You can flip through your notes with me as I do this. This is the first page in density right here. The next page are these problems, and so this is what we're calling worksheet number 1. Okay, so you can feel free to highlight this if you want, but this is worksheet number 1. And then when you keep flipping this right here, these are density problems. Okay, there's some examples on this page, and down here this is worksheet number 2. Okay, these problems right here, and then last but not least is this page with the graph on it, and this is worksheet number 3. Okay, so this is kind of where we're at with these 3 pages. The very last page in this is a table of characteristic quantitative physical properties that kind of goes with the density stuff, but this is an important table because it gives you a whole bunch of densities, some densities of wood, densities of other common substances, and those are all kind of down here. So it kind of loosely goes with that. Depending on your version of the notes, you may have a repeat. There's no reason for that other than my mistake. So let's kind of go through density a little bit, and we're going to talk about kind of how we solve density problems. So density is a measure, of course, of how much mass is contained in a given volume of a substance. Okay, so it's how much mass is in a given volume. And so we have a density triangle right here. Really, this density triangle comes from our formula. Density is equal to mass over volume. Okay, or D is equal to M over V. And this is it. This is kind of where it all comes from. And so this is one of those things that you need to kind of remember as we go through this unit. Now, to help you and to kind of help your memory, we have this density triangle right here. And this density triangle can help you when you're answering these problems. So, for example, let's say the problem asks you to find volume. The way that this formula works would be that you cover up volume with your finger, volume equals, and then you've got M on top of D, so that's mass divided by volume, mass over volume. And you can see right here from this formula that would actually be the correct formula. Volume is equal to mass over density. So if you're someone, and we know that this is grade 9, and some of you are still kind of getting used to the hang of algebra and rearranging equations, if you're okay with rearranging equations, fantastic. Just use this formula that's inside this box right here. Just use this right here. If you're not 100% okay yet with rearranging equations, that's fine too, because we've got this little density triangle. So another example would be if the problem is asking you to find mass, then you can cover up the M. Mass is equal to density times volume. And of course, you'll notice down here in this last line that's correct as well. Okay? So this is kind of how we use the density triangle and how we're going to solve problems. This is something that we want to introduce. When you solve density questions, or really any kind of problem, word problems, this is how you should list them. You should list your given information. You should list what's required, what the problem is requiring you to solve. A stands for approach, or your analysis, so like what formula you're going to use or how you're going to tackle the problem. S is solve, or create a solution, and the last S is, then always remember, a statement. So we always list our given information. We always then follow that with the required information that we need to know. A is the approach or the analysis. We're going to solve it, and then we're going to do a statement. So here's worksheet number 1, and I could do one of these for you as an example, and I think I'll do that almost right away. I'll pick one of these and do. Let's do number 1, and this is going to be your example, and then we'll kind of do the rest of these objects. So an object has a mass of 60 grams and a volume of 20 centimeters cubed. What is its density? So the way that we're going to solve this, and I'm just going to zoom right on in, and I'm going to use a very fine pen. So we know that the mass that this object has is equal to 60 grams. And we know that it has a volume of 20 centimeters cubed. The problem is asking for the density, right? So I've listed my given information right here. I've listed my required. Now I need to find the solution or the equation that I'm going to use. This is my analysis. I know that density is equal to mass over volume, so this is what I'm going to use. And now I'll solve it. Density is equal to, and I'll sub in my numbers, 60 grams, divide by 20 centimeters cubed. When I simplify this, I get 3 grams per centimeter cubed. And I'll finish this off. Therefore, the density is 3.0 grams per centimeter cubed. Now pay attention to little things like this. Like I said 3.0, here it was 3. Sometimes the instructions will say round everything to 1 decimal place. And that's fine if you want to do that. You can round things to 1 decimal place. These instructions don't say, so I just rounded it to one decimal. But that's kind of how we do this. Now on the iPad I can write really, really teeny. You're not going to be able to write as small as me. So what I'm going to suggest to you is that you do 2, 3, 4, 5. You do the rest of these when it comes time to do them. Tomorrow in class is when we're going to start tackling these problems. You do them on a separate piece of paper. Going down the list, and depending on how the class schedule goes, these are some alternate methods right here of solving density problems. And I will invite you to look through these. This is using unit analysis, where we kind of pick, we're not using the density triangle at all, we're just analyzing the units to simplify, and this is very, very useful in chemistry. We're not going to run through it, but you are more than welcome to use unit analysis. This is worksheet number 2, but that'll be assigned on a later day. And last we come to this little applications of density worksheet, and I just want to show you a couple of things. If we create a graph of mass versus volume, okay, we can also find the density from this graph, and we do it by creating a line of best fit through, say, some of the data, and then by interpolating any point along that line, right? So when we say, what is the density of substance 1? Well, substance 1 are these blue diamonds, and we do a line of best fit through this, and then we would interpolate and we would dash up and over. So we're going to do an example of this right now. I'm going to grab my little ruler here, and I'm going to show you what I mean. So now, as you guys know, because you've seen me do this in class before, this is very, very difficult. Now, I'm going to take this like this. Okay, there we go. That's better. So here we have a line of best fit that I've just drawn through these dots here, and I want to know the density of substance 1. So there's the line of best fit for substance 1, and basically what I can do is any point along this line, like you can see how hard it is to draw a straight line on an iPad, any point along this line I can basically go up and I can analyze. So let's take this point right here. We're going to take this point right here, and I can simply read off, okay, so this is going to be right here, 22, 4, 6, 8. So this is 22 mils, and we'll go over, this line dashes all the way over to here. This is 4246. This is 46 grams. And so what we can do is, if we want to show our work, we come in here and we do a dashed line using a ruler, which is very hard to do on the iPad. And then we do a dashed line like this using a ruler, which is very hard to do on the iPad. And you go over and you say, okay, so if I show my work, I've done the things, I know that density is equal to mass over volume. So for the point that I've just picked, the mass was 46 grams. 46 grams. And the volume was 22 milliliters. 22 milliliters. And so 46 divided by 22, if you do that little calculation, you get, oh, well, this is almost 2. This is almost 2, right? Because 44 would be twice, so this is like 2 point, and you can put this into your calculator, and you can find out exactly what that decimal is. You hear me opening my calculator. 46 divided by 22, 2.1 grams per mil. Okay, so that's kind of how you do this. So there's some analysis questions. There's some questions down here for you to answer. This is kind of worksheet number 3. And this is what we're working on over the next couple of days. All right, there's your lesson.